Hi, I'm Ben-Yaakov. This presentation is entitled Simple Gate Driver for Switched Capacitor Cell Balancer. In a previous video, which I've posted in my YouTube channel, I've shown that there is a way of balancing, say, batteries or, say, supercapacitors by a switched capacitor arrangement. In this case, we have capacitors which are switched between two adjacent batteries. Say, in this case, this capacitor is connected to the upper battery and then to the lower battery by these switches, and by this the battery with the higher voltage will actually transfer energy to the battery with the lower voltage. So eventually, when this goes on, all the batteries will be sort of balanced out in terms of the voltage, which is pretty much the state of charge, assuming that the batteries are sort of similar. So here is more detail about this switching effect. Here is the array, this is the array, and here we have a case in which the upper transistors are on, and here this capacitor is connected in parallel to this upper battery, and then in this case the lower switches are on and the capacitor is connected to the lower battery. So this is the way it works. Now, a major problem here is, of course, the drive, because we have gates here of MOSFET which are sitting at a higher voltage and we have to drive them. We are driving all the upper transistor together and then all the lower transistor together, but still we need a drive for these floating transistors. So here is a suggestion which is very simple to implement, doesn't require any isolated drive or transformer, but just decoupling capacitors. So here I'm showing just one pair, this two transistor around this cell. This is a P-channel transistor, this is a N-channel transistor. Each one is connected at the gate to a Zener diode, which is just for protection, although we are using the diode of the Zener. I'll show it in a minute. And then we have this decoupling capacitor, which is sort of buffering the voltage that we have here from the driver, which are referred to ground, while this portion here is sitting at a fairly high voltage, depending on the number of cells we have. So let's see how this thing works. Let's start with the N-channel part. I'm showing here a offset voltage. So the source of the transistor is sitting at a voltage V sub B above ground. This is the source, this is the gate, this is just representing the input capacitance of the gate. Here is the Zener. This is a bleeding resistor, just to keep the gate at zero when there is no action here, no pulses. And here's the capacitor, and here we have the drive, referred to ground. Now, the voltage on this capacitor at steady state will be this voltage here. Now, the reason is that if here is zero, then we have here V sub B, this is a diode, and therefore here we have this voltage on this capacitor. So now, if there is a pulse here, it'll be seen here, however, riding on V sub E. So here's the pulse, and here VGG, this is this between gate and ground, we see this voltage. This is actually V sub B, and here's this pulse riding on it. And then, of course, if you look just at the voltage of gate to source minus V sub B, we get back the same pulses that we had it here. So this actually translates these pulses which are referred to ground to pulses which are referred to this point here, to this source. This is actually called a DC restorer because it is sort of restoring the pulse to, in this case, it's not ground, it's referred to this V sub B because the diode is clamping this capacitor to V sub B. Now if we look now at the P-channel, it's very similar. Source here is sitting, say again, let's assume V sub B. We have now these pulses coming in. The pulses which will turn on this transistor will be this part here. This is 0, but this is the part that will actually activate the MOSFET, because we have here the pulses. Now again, the voltage across this capacitor is V sub B, and therefore we see here, we see V sub B and then the pulses, this part here below it, and therefore the voltage between the source and gate will be, or the gate voltage will be negative with reference to the source during this part here of the original pulse. So by this arrangement we can very easily feed the gate drive to all the transistors which are floating, and I'm showing here. In fact, we need only one driver, maybe some resistor for sort of buffering each gate from another one, and then of course we have to make sure that we have enough current to drive all the gates, but basically this is a very simple arrangement. So this brings me to the end of this short presentation. I hope you found it of interest and perhaps it will be useful to you in the future. Thank you very much.